Today we're going to be talking about laws of exponents. I'm going to try and have my best handwriting today for everyone. An exponent, we're just going to start with a little bit of vocabulary, is also called a power or a degree. And it tells us how many times the base, this is the base, will be multiplied by itself. Okay, so we're going to identify the base and the exponent and then write out what that means. So we've identified this is the base. This is the exponent. And what this means is we're multiplying x times itself 5 times. So 1, 2, 3, 4, 5. X to the 5th is the same thing as x times x times x times x times x. We can use the laws of exponents to simplify any problems that have an exponent. The rule we're going to be talking about today is the product property. And what the product property tells us is that if we are multiplying powers that have the same base, so if this is the same, we're going to add the exponents. And we can see here in the example, we have an a and an a in the base. A to the m power, a to the n power is the same thing as a to the m plus n. One thing that we need to keep in mind is that all variables with no visible exponent have an exponent of 1. If we just see an x, it's the same thing as x to the first power. Let's try a couple examples. We're going to start with, and I'm sorry this is so blurry, x squared times x to the third. Well, I can see the bases are the same, so I'm going to add the exponents. X squared times x to the third is the same thing as x to the 2 plus 3, which is x to the 5th. You may remember from previous days that we can use Desmos to check this as long as we add sliders. We use sliders to check, and we don't use x. So I'm going to try using m. Whoops, sorry. I'm going to add a slider. I'm going to set it to a number other than 1. And this should be equivalent to m to the 5th, and it is. So we've done this correctly. And I'm going to save this and I'll share the link with you guys in the HyperDoc. Let's try another example. We have the same base. They're all x. So we're going to just add the exponents. X to the 2 plus 3 plus 5, 2 plus 3 plus 5 is equal to 10. Oh, let's check it. I've used n here. We started with n squared times n to the third times n to the 5th. We found that it simplified to n to the 10th. Let's set this to something other than 1. These numbers should match, and they do. So we've simplified that correctly. One final example, and this is the tricky one because this is where our invisible math comes in. We have to keep in mind if you see an x with nothing next to it, right? It has an invisible power of 1. So we have x to the 4th times x to the 1st, which is the same thing as x to the 4 plus 1, which is the same thing as x to the 5th. And remember, we could write these all out too. We have x to the 4th, 1, 2, 3, 4, times x. How many x's do we have? We have 1, 2, 3, 4, 5. So x to the 5th. Let's check it on Desmos. So we had x to the 4th times x. We found it to be equal to x to the 5th. I'm going to add a slider. I'm going to set it to a number other than 1. How about -2? These should be equivalent, and they are. So we've simplified this correctly. I hope this was helpful. If you want to move back on over to the HyperDoc that the Algebra 1 team has left from you, there is a link on there for you to practice on Desmos. I hope this was helpful. Thanks for watching. Contact your teachers if you need any help.